go for it? Okay, yeah, typically a model where you provide any sort of data in terms of text or images, sound or movies, and there are specific embedding models for all of them, right? There are foundation models, there are multimodal models, right? Now, what they essentially do is extract the meaning out of the content, like, and then provide something called embeddings, which you see on the right, which essentially we call them as, vectors. So it's going to look something like this: a text on the left generated as an embedding model, and then the array is going to be dimension. Right? Now, what's happening under the hood is something. Now, what vector search does is it can objects or content or text which have similar relationships with each other. So in where it goes into the graph. And like a similar patch on a big vector space. Like our galaxy is a vector. What you then do is when you pass a query and when you go and do, you're finding distance between the objects themselves, right? So if you're providing, for example, a content something like a red shirt, even though you have given an image, so it actually understands when you provide as a text, it understands the context, it goes and sort of searches that information and pulls across from that vector space, right? Now, a bunch of results obviously would come depending on the query that you passed, right? And now, vector search is one concept. Now, from an LLM only mode, right? So when you operate on an LLM only mode, so these are the challenges, right? So number one, LLMs can be outdated based on their training data, right? So it does not know your data. So it does not know the context until you go and, fine tune them with your data. It doesn't have or doesn't know your data. Now what that happens is they will start to hallucinate, right? Now, when you provide a query, they're going to start to hallucinate. And then obviously there are a lot of limitations in terms of the number of tokens, and this phase is constantly evolving, right? So when we started a couple of years ago, the tokens were really limited. Now we have got like really large models that can take up a huge amount of token, but you pay for that, right? Essentially, that's what the LLM is, and unless you host them on your own on the on-prem version. Now, retrieval augmented generation sort of addresses that gap. So what essentially means is, let's say you've got some domain-specific data. You fine-tune the model with that, and you're basically, the model has learned about that. So the basic example could be, let's say you want the LLM to now speak Vietnamese language. You would essentially fine-tune the LLM with, a bunch of Vietnamese data, and it essentially start to speak in Vietnamese language. So that's essentially the fine-tuning or pre-training work. Now, from a RAG perspective, like your own data, you would take them at runtime based on user's query. So that's the retrieval part. That's where the vector search and all of the other concepts we'll talk about today comes in. Now that goes into the context window of the LLM itself to provide a much better generation. Right? So obviously for LLMs, garbage in and garbage out. So the challenge that we have on all of the generative AI use case is not only the LLMs, it's actually the content or the context that we pass to it. So how accurate and how relevant is the content, you're going to have much, much better response. Okay, so from our customers, right, everybody like started off with, I'm going to build an AI assistant, I'm going to build a RAG pipeline. And the last couple of years, they did a lot of demos, a lot of talks. But essentially, these are the things we learned from them in sort of taking them to production. And even some of them are still, sort of evolving, right? Now, What is the first thing is, what is the time taken? Right? So essentially, it's a completely new space, or the way we have been developing software has drastically changed for developers, right? So obviously, there's a learning curve. So how fast you can ship these apps, right? Now, how do you measure accuracy? So that's the key, right? So how do you actually measure accuracy in terms of, because you're going to put an AI assistant, or you're going to put a production pipeline, which is actually dealing with your customers, and you want that to be, spot on, right? You don't want that to be hallucinating and all of that. So how do you measure that accuracy? Now, the other things are around, like, how do you trace, how do you log, how do you monitor, all of the things that, how do you scale, right? How do you do it with much lower latency? All the challenges we used to have as the software, and all of them exist, right? But it's slightly done in a slight different way. There are different open source platforms, different techniques and stuff and tool sets to do all of this, right? Okay, so these are some of, like, my thought process that I've done, but there's a lot more, right? So from a ingestion perspective, so let's talk about getting your data into some sort of a vector database that stores embeddings and gives you that vector search, right? So there's a lot of data cleansing, data aggregation, enhancing of your data, and also in terms of, like, chunking strategy, how would you chunk, so there's concepts like semantic chunking. So when you, like, break a document, or even, like a structured data, how do you actually chunk them so that, when you provide that as a context to an LLM, they are smarter in terms of their responses. And there's a lot more in terms of, let's say, tagging, associating metadata. So you've got a financial report, for example, for year 2023, and you've got a financial report for 2024 for a company, and they typically are almost similar. It's just the data is different, right? Now, when the user is actually asking you a question, how do you narrow the vector search specific to a 2023 document, for example, if the user is actually asking for it? Or how do you compare the results of the financial results of a company between different? So that's where, like, metadata tagging and all of that, and hybrid search and other concepts come into play. Another thing is, how do you restrict data, like the roles and permissions, a lot of other stuff. Now, from an embedding strategy as well, so which model to choose, which dimension for the right level of data, and do I need a multimodal embedding, and so on and so forth. Now, uh, this is like assumption that, let's say, you're building a AI assistant, right? Now, starting on the left, like, you're taking a bunch of queries from user, be it text, voice or image or whatever it may be, right? You would essentially, as a first step, do that translation, right? And then you would apply some guardrails, right? So this is where the security comes into play, right? So you don't want your AI assistant to take garbage. So and also it has to take in only those questions which are appropriate for your organization, right? So that's where the input guardrails come into play, right? So for example, a user specifically asking for a product information. So how do you detect is, like, sort of classify the query and maybe rewrite the query so that you can do much better retrieval, right? So we call something called named entity recognition. There are cases where you detect intent and route appropriately, right? So user can ask question about various things to your AI assistant, right? So how do you detect the intent of what he's asking and then route accordingly, right? How do you go to the right data source, or how do you use the right LLM for that particular query, right? So all that comes into play, and then you would embed that and then query, sort of uh, perform a search, right? Or vector search or hybrid search, or even just a normal query to your database to get the appropriate data. And that's where you sort of employ all the indexing strategy, right? So there are techniques like HNSW, which various databases and data platform use, and there's another thing called DiskKNN, which is like Microsoft one, And like we created something called JVector, which is an one which is having really good performance in terms of very high recall for the results that come out of a vector search. So that's very key for accurate context coming out of that. Now, graph, we'll talk about it later on how we do that, but sometimes your data is sort of, you can build a graph model on related data sets, right? Even on a document, for example, right? So there could be an image which is talking about how do I switch on this projector? Let's say that's a projector manual, right? And there's another textual info that's talking about it. Now you want to relate this to this picture. So when you retrieve, you're able to, give a much more better response to your customer. So you can build relationships of various data, and then from those graphs, so you fetch the actual results and then go and fetch relevant data, and finally then you do sort of a re-ranking to get the best context or the content out of that. Right? There are other things like short-term memory, long-term memory, and stuff like that. So, for example, your previous question is the short-term, right? And you need that for an LLM as a context so that it responds or it understands. Okay, the first question was something about the projector, and next he is asking about how do I switch on without even telling a projector. So you need that context of previous questions and response, which is essentially short-term. But if you think about something he's asking about an order that he placed and on your AI assistant, then you would essentially need a long-term memory because you would have created an order using your AI assistant maybe yesterday or last week. So a lot of other short-term memory and long-term memory or history that goes into all of this, and then from various other data to then provide a much, much better sort of response. And when you provide that, you then employ output guardrails. Like these are governed principles that within your organization on how you want that response to be, right? And that's how the LLM would essentially then respond to the user. And then you track all of this, evaluation metrics. So there are open source platforms that give you, these sort of metrics in terms of tracing, logging in each individual step of the workflow, and also giving you metrics about accuracy, relevance, and all of that. So you can continuously then improve, right? And then there's also feedback channel. You can take human feedback, you can take a feedback from a tool, and so on and so forth. So I'll pass here for any questions. I mean, there's a lot on this one. Okay, perfect. I'm doing a great job. Okay, so introducing Datastax, right? So how many of you have heard of Datastax before? Perfect. Yeah, a few. Okay, so just a history, right? So we started off as a Cassandra company, right, with the database background, and then moved on to streaming with open source Apache Pulsar, and then with vector search and with Langflow. We have now moved on to the Gen AI space, right? So I'll be showing you the demo of Langflow and all of the platform. Now, Astra is nothing but the SaaS offering of our data platform. And Langflow is essentially a low-code, no-code Gen AI platform with just drag and drop tooling that allows you to, build. No, all of the things are all open source. It's just that we offer them as a SaaS for you to get started, but nothing stops you from going to the open source project and then running them yourself. We supported agent. We'll see that demo today. Now, all that in combination allows you to sort of go to production much, much faster. Right? So that has been our goal for like the last couple of years. All of our innovations has been around that space. Now, if you look at the Gen AI sort of stack, you have your dev tools, right? Typically in the Datastax world, we call them like the Langflow, which is low code, and then we have something called the data API that comes out of the box, which sits on top of the data layer. And then you've got the underlying data store itself, which is essentially the persistent store, which is the Cassandra database, which is vector search enabled, that can store billions of embeddings and do a very fast, quick vector search on them in the order of milliseconds. And then you've got the techniques, which essentially we call the knowledge layer, right? So that's where your vector search, the ability to perform graph racks seamlessly, the ability to sort different sort of multi-vector. So there's something called Colbert, which is another embedding technique. And Astra can store Colbert embeddings as well, and then the normal embeddings also. And hybrid search is another landscape where we allow to filter and narrow down to. So going back to that use case of 2023 document, you can filter 2023 and do a vector search on it. And not only that, we have integrated with re-rankers of Cohere and NVIDIA and all of them to provide you with the re-ranked results in terms of hybrid search. Right? Okay, so now knowledge graph. So maybe what is a knowledge graph, right? And anybody have already done a use case around graph rack? Yeah. Okay, perfect. So what essentially works is if you take a textual, for an example, textual data, right? When you chunk the data, you sort of give it to a graph extractor to extract some metadata to form link of each chunks or from your documents, and then you store them as sort of metadata and form a graph model of the representation of the entire data set. Now, what it is useful for? Primarily for relationships, right? Now, the way GraphRag works internally within like Astra, and essentially this is if you implement it on your own with frameworks like LangChain or with another graph database, you would essentially end up doing this. Right? So what would happen is you would essentially retrieve the approximate nearest neighbor, is what ANN stands for, which is essentially vector search. You would get the most relevant documents. And for each of the relevant document, you would then go and find related documents through your graph edges. And then finally, you would then re-rank them based on, distance or diversity, and you can tweak how you want to re-rank the data and all of that. And this has proven to improve the relevance rate to a much, much better level, much better than vector search, right? Because it's not only getting the relevant data, but it's also getting related data for the relevance.
Time you need, or is that part of the initial training with massive storage?
Sorry, come again.
So the as they're needed, like as you get to this vector point and then you build the graph. It's required, or is the graph built as part of the foundation?
Okay, so this is the retrieval part, right? This is, but I think you're asking more about ingestion part where, so that's during the ingestion is where the graph model is constructed. So essentially what happens is, let's say each row or each chunk is a row in the data store. And then you have metadata, which are essentially links to another row or another chunk. And this happens during ingestion. During the retrieval, it's only fetching the related graph edges from the DB. Okay, so introducing Langflow, and predominantly we'll see a demo of this today, right? Now, what that offers is it provides rapid development for you to sort of, prototype and take that to production, right? And then it integrates with various, observability tooling in the GenAI space, right? And it's completely low code, but still provides you the ability to edit and create your own components and stuff like that for your organization. And it's completely based on LangChain, right? So it's just that each of the components are essentially LangChain. So if you are already familiar with LangChain, I mean, this is going to be really, really a smooth transition. But it gives you much, much faster or rapid development space, right? Now, there's seamless integration with number of vector DB and also with our Astra. And we released sort of agents as well, like 2-3 months ago. And now we have onboarded like yesterday with, MCPs and stuff like that online. Okay, now around the Cassandra as a database itself, right? Now it supports different sort of data models to store and different for different use cases, right? So you would essentially compare something like it can be used as a key value like Redis because the response times are like milliseconds. It can provide support for like BM25 and various other lexical searches similar to sort of Elastic. And again, it's same Lucene-based indexing, right? And graph rag, it's not a graph database like Neo4j, but just from a knowledge graph or graph rag perspective, it can help you on that basis. Right? It doesn't do store normal graphs and do a reversal like Neo4j or Tiger Graph or other graph databases, but from a graph rag base. And you can store JSON documents and all of that. And this is why, I mean, like Forrester rated us on like a hybrid database, which also kind of enables GenAI. As you can see, probably we are the leaders up against all of the hyperscalers and all of them. And we are really proud of it. In a very short span of time, we have gone to the leader space, right? Okay. Now, let's talk about agents, right? So why do we actually need agents? So you saw that diagram where I had a number of things that we needed to do, right? In terms of the RAG pipeline itself. Now, to do all of that just with a pipeline, you would end up building a lot. Now, the power of agent comes in when you give it to the hand of to the LLM, because they are so advanced. I mean, you have now reasoning model, and the one that Elon Musk released, Grok, is like really, really good. The latest one that I tried. So give the power to an agent, which is predominantly driven by an LLM under the hood. Now, what advantage you get is they can make decisions at real time, and they can actually take actions, which was essentially not available on a typical, a RAG pipeline, right? Now, so here now you can not just the vector search or just the retrieval. Now, with agents, you can feed them with number of data, like could be unstructured data, or could be structured data, or could be a vector search retrieve data, and a lot more, right? And then the LLM then sort of decides which data I need based on the user's query, and then it goes and uses that specific tool to fetch or to execute the query. So basically, you remember the routing and all of that. Instead of we hard coding and doing all of that, now the agent is actually making the decision on behalf of us, and then going into the right tool set to achieve the entire workflow. Right? Now, prompts are really, really important in terms of agent, like how you want the agent to, make decision, which tool to call on what. All of that essentially goes into the prompt of an agent. So it's really, really key. So with that, probably any questions? I'll probably quickly go on to show line flow and show a few flows there. And then we can again come back to slides. Any questions on so far? Okay, perfect. Yeah.
Question around how are you doing the evaluation when it comes to, let's say, like really working in industries where accuracy is super huge? So what's your workflow around optimizing for the embedded search algorithms to increase accuracy?
Okay, cool. So improving accuracy, right? So actually, during the cloud space, whoever gave us the flexibility to run workloads whenever we want to spin up something, and we actually paid for the cloud providers for that. Now, where the world is moving around now is whoever is giving better accuracy, people will pay more, right? So that's where. So that's a great question. So I mean, it's not a simple equation. There's a lot more. So to give you some context, I had this slide to come back right now. So for example, Arise is a tool, right, which is essentially open source, plus they have a SaaS. Now, there you can actually, observe, monitor, that gives you a bunch of metrics and a lot more, right? And there are a number of different other open source initiatives as well, right? So essentially, you measure the relevance, right, on various spectrum in terms of, okay, is the data retrieved from the content, right? Be it a vector DB or be it a normal DB, is that related to a question? So that's first sort of metric, right, that you want to track. The second is now something called groundedness, which is the LLM actually giving you the correct response with the user's sort of query. So that's the second sort of metric. And now those toolings actually give you all of those metrics, and the goal is essentially to keep improving that accuracy, right? Yeah.
So most of the time, what happens today is that you have basically a framework like Langsmith and so on.
Yeah.
That you push all these traces, all the the outputs of the LLM, and then you can apply all these LLM as a judge or all of these different metrics, or use, for example, like GEVAL and so on, or DPVAL, which is another framework, by the way, for metrics and so on, and then Langsmith it will show you will trace for you the evaluations for each one. Or you can also basically set up a dictionary, and the dictionary is evaluating each of the functions that you defined in the backend. And they could be binary outputs. So for example, 1 and a 0, if it pass the test. And then you can output the naive approach, basically that if you have 5 tests, for example, it will output, and the output only pass 3 evaluation, so it will output 75%, for example. So you can set up things like that in the backend, and you will all be traceable in Langsmith, for example.
Yeah.
Yes, I think that definitely makes sense. However, like it still has a feedback. So right now, people who are validating it are, let's say, the experts, and sometimes like they would know that hey, that's actually an incorrect answer. This is a corrected one. Can we take some traces? My Smith is one, my Fuse is another. So there's a lot of applications that have different traces. It's still a pretty slow process from going from traces to like, oh, let me update the server, let me update the pipeline. How can we speed that up? Or if we have a correction that just gone and dynamically updated that step?
Or if you identify a pattern from the data from the set itself, because Langsmith is again a data set. If you identify a pattern, you can set rule-based to the backend of the agent itself, and then by that to improve the performance. But it does require experimentation, to your point.
Yeah, absolutely. It's sort of like, you're trying to learn from your production, right? So same as like what we used to do before, like when we monitor, right, to do all of this. Now, to answer your question, can I magically do with an automation and deploy immediately? Right now, I would say, I mean, it's not there yet, right? Because you can find that, hey, your accuracy is dropping, maybe your feedback on the answers are low, your accuracy is not great on certain questions, right? Now, like to answer his question on evaluation, so one of the technique customers use is something called ground truth. So what they do is based on the data set, like be it a doc or maybe an FAQ or something. Now they first generate all different sort of questions that could come from, it's called chain of, it could come from there, right? So that's your ground truth. Now that ground truth data is then fed to toolings like Arise or Langsmith, and that's where, let's say the real answer comes back and you have got them as a trace here. Now an automated evaluation happens with the sort of ground truth data because you've got that, and now that, hey, it's actually the response is not that great for this particular, question, right? And that you can take it as a trigger, and then you come and see, look at, hey, do I need to augment with additional data sources? Do I need to look at my retrieval technique? Do I need to, look at my, LLM prompting, for example? Some cases could be fixed with prompting. So there are a number of ways to improve relevancy, but the question right now is to find that problem. So that problem is solved, but then you'll have to make changes to your pipeline and then ship it to production, as we do normally bugs on our standard development practices, right?
That the Gemini 2.5 is good now, and it's expected to have a contact window of about 2 million. Would that change this whole complexity that we have developed to devise something?
Okay, is the question more around, will it eradicate RAG itself?
So,
Or
I'm not saying it's simplify it and help it to, do less, dump it all into one big question and then give it to answer.
yeah, so to answer your question, but still, if you, let's say you've got an FAQ, which is like of, 1 lakh lines, and then you're able to pass the whole FAQ into, let's say, an LLM, but it's still not relevant to that question, right? In my opinion, RAG will still exist because you're giving the right text for the right query that the user is asking, and not the entire chunk of your data every time to the LLM to process, right? And that's also typically not cost efficient or even compute efficient, at least for now. But maybe as the LLMs evolve, it might change.
Yeah, I'm not saying it will like that. Just saying it will help a lot. Make it done with 3 different years of say companies.
Yeah.
And then you know which one to choose from.
Yeah.
Well, right.
Yeah, absolutely. And in fact, like even your chunking strategy, for example, you could have like bigger chunks of data, right, which are sort of relevant. For now, people used to, like retrieve not just the top 5, like the top K, maybe retrieve top 30 and still pass the whole thing because the token limitations were there, right? But now you're right. The chunking, you can have bigger chunks of data. All of that will change. But yeah. Okay, so just going back onto this, right? Okay, I'll finish off and then go back to the demo. So now with NVIDIA partnership, what we are trying to do is, a lot of our customers not on cloud, right? So they want like a self-managed stack, the entire, right? Now with NVIDIA, they've got all of the essential stuff, right? NVIDIA is not just the hardware, but they have amazing sort of software microservices around this space. Like, for example, NVIDIA NIM has a lot of stuff that you can actually potentially use. And NEMO guardrails is one of them. Like, I remember the diagram back, right? So the input and the output. And there are a number of other security platforms that offer guardrails as well. And then you have like Retriever, NVIDIA has their own embedding models and all of that served through NIM. And the other things are like, the curator, evaluator, and customizer. So those are typically used for fine tuning of data as well, and then constantly, like, for example, the evaluations, right? You could use a NEMO evaluator to, you can have all of them within your complete rack pipeline. Now, all these software components, we have given a Langflow component to this, right? So you can technically just drag and drop all of them to build your sort of pipeline, right? And even from other partnerships we have is, like things like Unstructured and a lot of other libraries, specifically open source platform that work on better chunking strategies and better extraction of data and so on and so forth. Arise is one of them, but there's a number of them like Langsmith and so on and so forth. Okay, perfect. So this is Langflow. So typically you would go and say, I want to create a new flow. Do you want to create a simple agent or a vector store RAG or some basic prompting? And then you have a number of other use cases where you can pick up a template, like you can build a financial agent, you can build YouTube analysis, right? All of them would essentially create a new flow straight away for you, right? So for example, if I go in with the box. Now, if I go in, for example, a simple agent. So before I go into agents, so the components that you see on the left, right? So all of them are drag and drop components, as you can see, right? Now for prompting, for data inputs, right? You can get data from a S3 bucket or a file and so on, or a directory. And then you have number of processing tools like to filter data, like you have LLM routers and a lot of other options out there. And there are all of those models already pre-built and ready to go, including open source models. Like if you run on your own laptop or in your self-managed with Olama, you can just drag and drop Olama and use your own model. Open router is another concept where you route to LLM based on sort of query and things like that, right? And Vertex AI. So pretty much most of it is there. From a vector store perspective, you've got all of the options, right? Including Astra, all of them, right? From embedding models, you have number of options again, and you have agents and tools. So tools are great. Like tools are the ones you pass to an agent, which then decides to use one of them, right? Okay, so for example, I have a basic calculator agent, and then here is the instruction for the agent that goes. This is the basic one. And then I've got a URL, for example, here, and then to run, you get a playground. So maybe let's ask some questions. Or just same question or something different. So what essentially happens is it's going to go and execute this flow. So first, it's actually doing the URL fetch now, and then so it happened is the agent decided to use this is an MCP server, but just assume this is like a URL search component, right? So it went and found where to where is the weather in. Right. Now, so the entire code for the agent is right here. So you can completely customize, like I said, all of them is completely Python LangChain based components. So you can customize this and create your own new custom component and save them for your own pipeline. Now, code. So from your own application, just call the sort of agent with your own inputs here. So here, and then that goes as a tool to one of my agents. First one, city selection. I'm looking for a Leh Ladakh trip in Jammu and Kashmir, right? Give me all of this sort of data to it, right? And it gives me a various itinerary on what I should be doing on day 1, day 2, based on all of my sort of interests. And you can do all of this pretty much chaining them with number of different other agents for specific sort of work and specific calculator actually to compute the budget, right? So it gives a total budget of how much and all of that based on the cost and so on and so forth. Sorry, was there a question? Okay.
Just with memories, is that we just add memories on two places rather than
Yes. So yes, it's basically like the short-term and the long-term memory we talked about on the one, right? So you drag and drop, and then at the end of the chat output, you hook it up to this component. It's going to go and persist into database, and you can actually retrieve it while you're doing your retrieval as well.
Like before you mentioned some of your customers, but self-understand.
Yeah.
Yeah. So you actually the two drivers why those customers are creating self-understand as compared to
Absolutely, great question. So now, right. So number one is security, right? So not everybody is comfortable in sharing their data, their context to LLMs which are in the cloud, and typically the reasons being they fear that they will use that to train. Let's say OpenAI might use it to train that, right? So that's a lot of customers use an Azure OpenAI stack. At least they know that it's in their VPC and not if they want to go with cloud. But yeah, number one is security, and number two is cost. So because the LLMs is all about tokens, and if you look at our diagram previously, there are a number of LLM calls, and with agents coming into play, you have so much use of LLMs, right? And typically all our customers, they tell us, hey, we pay like really less to you guys to build a chatbot, but we pay a lot to OpenAI, right? Because you guys are so cheap, but OpenAI, we pay a large sum of money. So cost is another reason. So they typically want to host open source fine-tuned LLMs on their own. So it's only the compute cost, right? One-time investment from a GPU perspective, but you're not paying for every call.
Maybe one other follow-up question. The demo that you're showing.
Yeah.
There's an option to use Olama services.
Yeah.
Probably the locally hosted element.
Yeah.
What kind of usage that you see over there? Is it more enthusiasts trying to play with the element on their machine and trying to piece together a workflow, or is it production-based kind of applications?
So Olama is sort of a mix, right? So like I use Olama on my laptop mostly, for talks and things like that. For production grade, customers go into a complete stack like NVIDIA, right? So that comes with the hardware and the software tooling with all the security and everything. Yeah.
You can download really thick models and video labs, but it needs to be there. Unless you're laptop.
Yeah, for production grade running on GPUs, technically, yeah, people like go into and Sambanova is another competitor, like which is from an NVIDIA, similar to NVIDIA.
So more in the corporate team, like with short and so on, they're also invested in this revenue game. But there are lots of like unrelated stuff in that flow, like in the version you case, right? So in terms of customizability, do you think like you can get rid of all the unwanted stuff in more this delightful easily, or is it like you need to actually go into the core and like go to do that?
Yeah, great question. So number of like customers have given that feedback, right, to us. So can I have my only those dependencies and only those components that I need for my enterprise to use, right? The answer is that is being built right now. So the open source community is building it. So it will be available shortly. Yeah.
Sorry, it's Langflow or it's
No, it's Langflow. So Langflow is completely, open source. So you guys like can go to the GitHub and, install it and play around. But the feature that you asked where you said, I don't need the entire tool set to be available, just I'll pick and choose the specific components. Yes, that feature is coming. So the open source is already sort of building, and there's a lot more pull requests so that are happening. I think one of that should be here that the open source community is already working on.
You mean like install sections of it? Okay. After the one, so lecture. So this plus install.
So right now it installs. So if you say install Langflow, it installs all of the the Python packages and the entire stack. But I think the feature is more around during my install, I'll pick and choose the one that I need for my organization, and based on that, the UI will completely change, and I'll have only what I need specifically. Cool. Maybe a few others. So this is like an ingestion. Like I've taken a small FAQ, split the text, just database, right? Astra DB in this case, and then a basic vector store RAG would look like something. I mean, this is really, really basic, right? So get a chat input, do the to an LLM, and then you get the out. So this is like the basic one. But then in real sort of production use cases where you would essentially move to agent based, right? So for example, I just created this just to show you guys, like for example, you have an agent, you have like bunch of tools, like I have some tables, orders, and then I have a table which is like essentially having my products, and then I also have the FAQ data, right, which is another collection which is going, and so like all of them working in conjunction, and like for example, I say, hey, can I cancel the order, this particular one? So this would essentially go and query whichever table and whatever data I need, and then come back with the appropriate answer. So this is already shipped, and you cannot really sort of cancel, right? So like a basic, and by the way, the Langflow is actually running right now on my local host, as you can see, right? And then the way you can actually call these ones. So I have a basic Streamlit app, right? That essentially runs this localhost, my specific flow, with the input as a message provided by the user, and then you have an API key for the Langflow itself, and then you have a bunch of code to like do all of the stuff. So a basic Streamlit app, like this could be your front end, right? So like for example, what is the return policy? Now, what is essentially happening is it's actually going and triggering Langflow right now. It's executing the flow. Now, the agent appropriately will detect that, hey, this is from an FAQ related question. So it would essentially use the vector search from an FAQ, right? Maybe a different question like, can I cancel order, right? This would essentially then mean I have to first find out what is that order. So I'll go into my orders table, find that info, and then, so let me show you, this is where I have the data. This is Astra platform, SaaS. So where I've got my FAQs data. So this is all my FAQs which are embedded here, right? Just a simple one. And then I've got my orders data, which is all, I've got my order 104 here, right? Which is in shipped status, right? And then that has an array of what are all the products, and then my data and the products is right here. So I know the mapping of, so the agent sort of orchestrates and finds out all of that. Cool. No, I think with that, probably I'll quickly finish off with, MCPs. So how many of you read about MCPs? Okay, awesome. So it's a great way. So think of this as, so what is the difference between a tool and an MCP? Anybody want to answer? What is a tool and what is MCP? How they are different?
MCP is model context protocol.
Yeah.
What it does is essentially it's like you build in a host and server, and you create this very type of tools that you want to make available for a client.
Yeah.
The client make requests from the MCP server, the tools that you basically appended to the server itself, and then it adds that functionality to an LLM.
Yeah. Okay. Perfect. Thank you. I think that's what essentially it is, right? So MCPs are created by Claude recently in 2024. So they gave a server client architecture to it, right? Now, what has happened now is, so now all of the tools, like MCP is like a collection of all the tools, and tools are actually targeted to the agents themselves. So agent contains tools, right? MCPs are targeted to users, meaning all of us, right? So everybody develops their own MCP server. So for example, Kong API gateway, you guys all would have used, right, or heard about it. So they release their own MCP where, developers can, go and do. And similarly, for example, like this is Cursor, right? So I have like 2 MCPs configured here. So if I go into my settings, this is all I need. So I say that, hey, Langflow, and this is the URL local, and this is the link to call all of the flows that I have in Langflow, right? And then you have AstraDB, and you give it an endpoint and the token and all of that. And then you basically then have MCP. So as you can see, all of the tools like get collections and all of the tools that is exposed by Astra database as an MCP is readily available. So like I can say, hey, how many collections I have in my Astra DB, for example. So if I go and ask this question on my Cursor AI, so it actually the LLM detects that I've got an MCP added, and this could be a better tool to use, which is get collections from Astra DB. So when I say run tool, now this is actually going to call my Astra DB MCP server, and it's going to give me all of these collections that I have in my Astra database, right? So for example, all of these ones. So these are the collections I have, and that's exactly what it fetched, right? And there's a number of things, like I can add data, I can delete data, and so on. So for example, here, like the Langflow itself. So all the flows that I created here in Langflow. So for example, we had this, we had this travel planning agent, right? Now, let's ask the same question as a developer. Like, it's so easy. So, like, if I say, go and ask the same question from Cursor, it will ideally detect that it's about an itinerary planning. And you can see that the travel planning agent flow that I have in Langflow is a tool here for, so everything in your enterprise. So it's actually prompting that, hey, this is the tool that I want to actually run, right? And then if I say, so essentially MCP is a much smarter and easier way to expose information to your LLMs, right? So more like a standard protocol has come in. So now this will go and run my Langflow under the hood and for developers. So everything is coming out. Like imagine now Salesforce or ServiceNow or your ticketing platform, everybody will give you an MCP, and like you can literally analyze your code, fix defects, and with bunch of commands, you can like go and update all of your systems, and this space is like growing really, really fast. Like we already have like more than thousands of MCP servers already available, and everybody is onboarding on this space. So this is going to be like the next way of sharing info. And it's much, much easier than what we are used to, like APIs and API gateways and things like that. This is really, really easy. So from a developer perspective, all I had to do was just add 1, 2, 3 JSON statements, and that gives me the power of, exchanging information for LLMs. Okay, perfect. So with that, I think that's all I have, pretty much. Thank you. Thank you, everybody. Okay, questions. Yeah. No, it's available on NVIDIA website and Datastax websites. Go for it.
Hi. I have a slightly broader question, I suppose. Considering you've seen now that a lot of folks take these sort of agentic applications into production, which sort of scenarios would you say that this sort of application now works best for?
You mean which use cases are better for generative
I
AI?
would just see like, your clients sort of taking it straight into production and you see how they sort of performed over time. Perhaps some systems require very low latency because of the sort of somewhat complicated architecture. Does that make it less useful in that sense?
Okay, so latency, how do we, improve our response time is a different, like complete different thing. But does it make me to stay away from these use cases? No, because the power that it can bring and the problems it can solve is a lot, right? So definitely everybody is embarking on generative AI, and like every CIO I talk to, everybody has got budget. And I was talking to eBay CIO, and he was like chatting with me for a coffee, and he said the only people who's not getting fired is who are on generative AI teams. So that's the level of importance everybody is giving. So I mean, this phase is for growing, right? This is like a revolution, like internet and mobile, or even much, much going to be powerful and faster. That's what everybody is predicting, right? Now, coming back to your question on use case. Okay, so the RAG and AI assistants and things like that was predominantly a lot more prevalent like last year or a year before. But with the agents and everything, now it's moving towards, systems of automation. So think about it. Every workflow, or like, let's say you had a rule-based fraud detection platform. Now, you can completely rewrite that with agents in a much, much smarter way, right? So the way we were actually building various use cases is going to drastically or fundamentally change the way we work with. Like for a developer, now you have a AI, cursor AI, and the way I write code is completely different, right? The same way, so systems of automation is the space where, and everybody is onboarding right now. Salesforce, for example, I was there in their event in Sydney last week, and it was completely agents, right? They are putting agents on every industry in front of their customer service, right? So same like ServiceNow. So every big organization and big product companies will bring in much, much powerful innovation in the hands of users. So developers now don't need to know anything that's happening under the hood. Like you saw the toolings that are available, right? So how fast you can do it with, as long as you understand the concepts and how to wire them all, like you're already an AI engineer. So there's a lot more use cases are being used coming up with customers, yeah, in the systems of automation space, integration space, everywhere.
I think the point there is that can you get visibility into each of the steps, but like debugging? If you're not getting the answers you require, that's what you'd say. How do you see where what might be happening where it might be going wrong, and what you might need to.
Yeah, so these observability tooling, they give you some or in fact better context. So for example, I think yeah. So if I go, yeah, this is probably lang chain, right? So this is like a chat application, for example, and then think of that whole rack flow, right? And each of the individual ones, you get to see what was the input, what was the output, and also essentially under the hood, the logs, and including what is the value for each of the things that you received and things like that. A lot more of it. And same with any other observability tool. So it's like the tracing and metric that we used to do, like this is exists for generative AI applications. So you can definitely debug and go and look at what's really going.
Plain English.
Hmm?
It's just in plain English, basically, the previous steps.
Yeah, end of the day, it's all still Python code, but from so how would you analyze? So here it's English, but then if you want to go deeper into each of the variables that each of the the code got into, yeah, you can go that deeper as well. Yeah.
It's like random floating point numbers.
No, no. Yeah, yeah. So those are abstracted. Yeah. So any vector DB would abstract that for you. All of
By the way, if you use like run chain, so what happens is that if you're lucky, it's a back. So you have like one studio, but otherwise in production, for cloud, you will have the same UI, and it will literally color red and note the configuration, and then you can just go to the.
Thank you for the demos. I'm going to ask you to like take off your Datastax hat. I mean, as people are trying to build products, like we're flooded with proofs in terms of database. How do you? What's your take on kind of decide between a vector, only DB, like Milvis? How should we be integrating with something like Astra? Should it be integrated? Like, how should we be thinking about this whole structured and unstructured data?
Yeah, great question. So, and even with the Datastax hat, still there's a lot more. I mean, in this space, like a lot more compete we have to do. We have to be better at our craft. So we do sort of compete with a lot of people and a lot of things around every day, right? So to answer your question, I think for every first thing is it depends on the use case, right? So first you have to arrive on what are the things essentially you would need. First of all, do you really need a vector DB, for example? Maybe your use case does not, right? Maybe just an agentic workflow is more than enough, right? Okay, so then other things, what all you would need, like from an observability perspective, from an LLM perspective, from do I need multimodal embeddings, or just are you dealing with voice, video? So depends on use case. You would have to then boil down to individual ones. And now, how would you choose between when you have various options for each of them? The answer is nothing is permanent, because the space is so fast. Like today, you are picking one LLM. Tomorrow, a new version of the LLM would come, and then you would obviously upgrade. But the upgrade path and the change cost we had for our previous application is low in the generative AI space. And the reason is because we have got advanced tooling that can help us ship faster those upgrade paths and changes and things like that. But from a vector DB perspective, again, there are metrics in terms of, what is the F1 recall, for example? What is the accuracy of the data that's coming out? What is the latency? How does it scale for billions of vectors? So there's a lot of parameters that would go in, which you would then evaluate, and you will look at probably performance benchmarks data to find out, hey, how is this? And same with LLMs, right? So there's a number of performance benchmarks data out there. A lot of third party and open source community are testing. Have a look at them, pick the right one. And it depends, right? So now with LLMs, now there's something called SLMs coming along, like small language models, right? Which essentially could go on mobile phones, edge devices, like Apple Intelligence. It's nothing but SLM under the hood. like Samsung AI is nothing but SLM under the hood. So they all run on edge. Maybe your use case only needs an SLM. You don't even need an LLM. So completely depends on use case.
It's when you're running like so locally, how do you production?
Okay, so the entire Langflow, this is right now running here, but it runs on Docker. You can put it onto any cloud platform wherever you want, pretty much. And then you would essentially, typically like any other software, you will need to size it, or you'll need to decide on how do you scale and all of that, right? So easier option. So Datastax provides a SaaS offering of Langflow. So if you are like, a startup, I don't want to be worrying about all of this, maybe, yeah, or even the enterprise who is SaaS native or who prefers SaaS first approach. Even a lot of big banks are now SaaS based. Like, I mean, one of the customers was telling, I was showing them all self-managed, and then they said, no, we are SaaS native. Show us your SaaS platform. Oh, okay, that's cool. So a lot of companies which adapt purely SaaS nowadays as well. So cool. Perfect. Thank you so much, guys, for your time and patiently putting up with me.